Okay, so we've gotten through 17. Calculate the molarity of 200 milliliters of a solution containing 100 grams of nitric acid. So it looks like a molarity question because they're asking us to calculate the molarity. So I'm going to say M equals, and we have 200 milliliters, and so we do 200 milliliters divided by 1,000 equals 0.200 liters. So we have a amount of solution. And we don't have a moles. Uh-oh, we have 100 grams. What are we going to have to do that? So we got to convert 100 grams HNO3 to moles. This has to be grams HNO3. The rules still apply. Units have to cancel. And 1 mole of HNO3. So we have 3 times 16 plus 14 for the nitrogen plus 1 for the hydrogen. So we have 63 grams in HNO3. So then we got to divide 100 by 63. That gives us 1.587. I'm just going to say 1.58. 1.58 moles. So now we can, it's just a calculation. It's 1.58 divided by 1.58 divided by 0.2 liters equals 7.9 molar. 7.9. So that looks good to me. Okay, so let's move on to 18. How much concentrated 6 molar HCl is needed to prepare 150 milliliters of a 2.5 molar solution? So I have a molarity, I have another molarity, and I have one volume, 150 milliliters. Looks like an M1 V1 equals M2 V2 problem. And the ones that go on the same side are the ones that are close together, or the one where it says 150 milliliters of a 2.5 molar solution. So I have a molarity, M1 is going to be 2.5 molar, and I have a volume, volume 1 is going to be 150 milliliters. And remember, it doesn't matter if it's milliliters or liters when we do this. It only matters if it's liters when we do a molarity calculation. So 2.5 equals, and I have a molarity, M2, 6 molar, times X milliliters. So it looks like 2.5 times 150, and then we divide by 6. So it looks like 62, X equals 62.5 milliliters of 6 molar solution. All right, not too bad so far. 19. To what volume should 125 milliliters of 10 molar H2S, what volume should 125 molar should be added to produce a 3 molar solution? Okay, so they're basically asking how much, and I see a volume, I see a molarity, and I see a molarity. So that's M1 V1 equals M2 V2. So M1 is 10 molar, V1 is 125 milliliters, equals 3 molar times X milliliters. And again, it's just 10 times 125 divided by 3. So it looks like 416.7 milliliters. X equals 416.7 milliliters. And there's our answer. Okay, how can you get oxygen gas to dissolve in a fish tank? Well, here we have a gas, NH3, and we notice that the solubility goes up as temperature goes down. So I would say I could cool down the water. If I heat up the water, I'm going to get less gas in. If I add more fish, they're going to use the oxygen more. If I add a solid solute to the water, that's not going to do anything but increase our colligative properties, and none of which is dissolving oxygen gas. So the only answer left is cool down the water. I know some people had some problems with that one. I hope the fact, knowing that NH3 is a gas and that as the water cools down, I can get more and more of this gas in there. I hope that cures you of any misconceptions you have about that. 21. What is the relationship between solubility of a gas and a liquid and temperature? As temp goes up, solubility goes down. Okay, we can see that based on this NH3 line, right? As temp goes up, solubility goes down. What is the correct relationship between solubility of a solid in a liquid and temperature? Well, all these are in a liquid, so that is just extra information. But all these are solids, so what happens is the temperature goes up. Solubility goes up as temp goes up. Solubility goes up. Okay, which substance is least soluble in 100 grams of water at 90 degrees? So this is simple. I go to 90 degrees and see what I can dissolve the least of. NH3. I can only get 10 grams of NH3 to dissolve in 100 grams of water at 90 degrees. All the other things are much higher, right? Okay, if a saturated solution of potassium nitrate in 100 grams of water is cooled from 70 to 40, how much precipitate will form? Well, it's saturated, so we know it's on the line. So 70 degrees of KNO3, so that's going to be right here. And that's 130 grams. And then I'm cooling the water down. Oops, put that in the wrong place. Hate when that happens. 130 grams. And then I'm cooling the water down to 40 degrees. So at 40 degrees, I can only get 60 grams to stay in solution. So 130 minus 60 equals 70 grams. That's your answer. If I can get 130 in at 70 and I cool it down to 40, then there's only going to be 60. The rest of it's all going to be a precipitate. We remember this term, right? And that's 70 grams worth. How many grams of ammonium chloride, NH4Cl, can be dissolved in 100 grams of water at 50 degrees Celsius? Okay, so NH4Cl. First I'm going to go to 50 degrees. Then I'm going to go up to my NH4Cl. And that's simple. It's 50 grams. 50 grams. Okay, at what temperature? No, I told you to not do that one because we're not going to solve for temperature. We're going to solve for grams of water and grams of our solute. We're not going to do that. I don't want you wasting your brain power on that. How many grams of potassium chlorate can be dissolved in 200 grams of water at 50 degrees? Well, this is a proportion problem, right? So at 50 degrees, KClO3, it looks like 20 grams. So I know 20 grams in 100 grams of water, KClO3. And then they're asking how many can be dissolved in 200 grams of water. So X grams of KClO3. Well, I mean, I can look at this and see there's twice as much water. And if there's twice as much water, there's going to be twice as many grams. So I can solve it that way. Or I can do it like a proportion and dissolve and divide 20 by 100 and then multiply by 200. But either way, you're going to get the same answer. It's going to be 40 grams of KClO3. Okay. Now, first of all, whoever made this sheet should have had this as 50 degrees Celsius. Okay, at 50 degrees Celsius, if a solution contains 80 grams of KCl, so first I'm going to go to 50 grams or 50 degrees Celsius, and I'm going to see how many grams of KCl it'll hold. It'll hold 40 grams. And how many grams of water are needed? Okay, so my ratio is 40 grams of KCl in 100 grams of water. And our other proportion is 80 grams in X grams of water. Well, again, if this is twice as much as this, then take a stab at how much water we're going to have. Twice as much. Or you can solve it. You can do 40 on 40, clear. 40 divided by 100, and then 80 divided by second answer equals, shocker, it's 200 grams of water. And I should put full units because I asked y'all to do the same thing. So grams H2O, it's 200 grams of water. And that makes sense. If I can get twice as much to dissolve, I probably have twice as much water, right? Okay. At what 40 degrees? Oh, you gotta love questions that are worded like that. At what 40 degrees, how much potassium nitrate can be dissolved in 300 grams of water? Okay, at 40 degrees, how much potassium nitrate can be dissolved in 300 grams? So, first thing I'm gonna do, I'm gonna go to 40 degrees, and I'm going to go to potassium nitrate, and I'm going to see that 60 grams, so 60 grams over 100 grams of H2O, and they're asking me how many in 300 grams H2O, and that's X grams of KNO3. KNO3. Okay, well, if this is 3 times as much water, take a stab at how many grams we're going to get in here. We're going to get 3 times as much. It's going to be 180 grams of KNO3. And that's without even lifting the calculator. But if you need to, 60 divided by 100, and whatever your answer is, times 300, it's going to be 180, isn't it? Yes. How many grams of NH4Cl will be needed to saturate 200 grams of water at 70 degrees Celsius? We keep using these very simple numbers. So first I'm going to go to 70 degrees. NH4Cl, it looks like 60 grams. So 60 over 100 at 70 degrees. 60 grams over 100 grams of H2O of NH4Cl, and they're saying 200 grams of H2O, X grams of NH4Cl. Well, again, twice as much water, twice as many grams, 120 grams. But again, you can solve it. 60 divided by 100 times 200, 120 grams of NH4Cl. Okay. We're going to have to start another video.